I'm Laura Jays. I'm going to take you on a tour of the Institute's Innovation Centre to showcase the incredible work that's continued unabated during the COVID-19 pandemic. You'll see the Institute's scientists creating stem cells to shed light on a deadly heart disease and hear how they're hoping to prevent sudden cardiac arrest.
This work, it has been affected by the pandemic, but yeah, we've learned to adapt and we've learned to cope, and things have been probably as productive as they can be. So we're focusing on trying to analyse all the possible genetic variants that occur in these genes that we know drastically increase your risk of sudden cardiac death. And about 1 in 10 of us is going to die as a result of a cardiac arrhythmia.
1 in 10? Well, who is most at risk?
Anyone with any underlying heart disease is at risk. Yeah, if your heart is not perfectly normal, then you're at risk. Now, fortunately, it's not common, but we're talking about people, say, between 1 and 30 years of age. And in the vast majority of those people, they're completely unaware that there was anything wrong with their heart to start with. And unfortunately, if you collapse and have a sudden cardiac arrest outside the hospital, your chances of surviving are only 1 in 10. So about 90% of those people will never survive. So that's why, particularly in that younger group, it's really important that we try and detect those people before they have that first event.
So the Synchro patch is one of your greatest weapons in identifying and treating genetic heart disease.
That's right. And it literally has increased our throughput about 100-fold. So in the old days, when we did these experiments, we could only do it 1 cell at a time. Using this technology, we can now load up cells into these plates and we can study 384 cells all at the same time.
So this machine, can it be said, is it literally a lifesaver?
It is, yeah. It's enabling us to make that definitive genetic diagnosis more quickly and in a much larger proportion of patients. So it's not just the odd lucky patient that benefits from our research. Conceivably, within the next couple of years, every possible patient around the world who has any of these variants in these disease genes will be able to help them.
The world of genetics has come a long way since the completion of the Human Genome Project in 2001. Since then, scientists have analysed the genes of thousands of people to help identify the cause of heart disease. The Institute's Dr. Monique Bax is now honing in on the genes of 14 women with SCAD.
So SCAD stands for Spontaneous Coronary Artery Dissections, and it's a major cause of heart attacks in pregnant women and women under 50.
And you have 14 women who've donated their blood cells.
Yes, we reprogram the cells, taking them from blood to stem cells in tissue culture. And then once we've established those cell lines, we can bring them to the Hamilton robotics instrument.
So this is how you look after those precious stem cells.
Exactly. We're able to use those to make SCAD in a dish. And that allows us to see if drugs will work, see what differences there are, and really get into why these women are at risk of having a SCAD heart attack.
Monique, why are you so passionate about your work?
I love being able to do something that helps people. I think you can make such a big difference, and we're very close to a breakthrough. We've been working really hard to establish these tools that we can use using these cell lines, and now we're at the point where we can start to really delve into the differences and understand these mechanisms that underlie SCAD heart attacks.